Chapter 6.1 to 6.3 by Jordan, Jonathan, Jack, and Matt.
6.1 deals with conversions. So first, you can convert each angle from degrees into radians by using the equation pi over 180. And then to convert each angle from radians into degrees, you would do the reciprocal of that, and you would do 180 over pi. For an example problem of converting a angle into radians, we can do 210 degrees into radians. So 210 degrees times pi over 180, and then you do the simplified fraction of 110 pi over 180, which gets your answer of 7 pi over 6. For the next example, we're going to convert radians into degrees. So instead, you're going to use the equation 180 over pi to get your answer in degrees. So you're going to do pi over 4 times 180 over pi. The pi's are going to cancel out, and then it's going to be 180 divided by 4, which equals 45 degrees.
These 6 basic trigonometric functions can be used to find and solve for the sides of a right triangle. We can remember them using the acronym SOHCAHTOA. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Cosecant equals hypotenuse over opposite. Secant equals hypotenuse over adjacent. And cotangent equals adjacent over opposite. For the first example, it is asking us to find the 6 trigonometric functions at 60 degrees. To find sine, we look at the unit circle and find sine equals radical 3 over 2. For cosine, we look at the unit circle and find it equals 1/2. To find tangent, we take y divided by x, which works out to be radical 3 over 2 times 1/2, which equals radical 3. To find cosecant, we take the inverse of sine, which is 2 divided by radical 3, which simplified is 2 radical 3 divided by 3. To find secant, we take the inverse of cosine, which is 2 divided by 1, simplified is 2. To find cotangent, we take the inverse of tan, giving us 1 divided by radical 3, simplifying to be radical 3 divided by 3. The second question is asking us to find the 6 trig values of 8, -6 if it's a point on the terminal side of an angle in standard position. First, we must find r. To do this, we take the square root of 8 squared plus 6 squared, which simplifies down to be 10. Now that we have r, x, and y, we are able to solve the trig functions. First, we find sine, which is y divided by r, which simplified is -3 divided by 5. Next, we find cosine, which is x divided by r, which is 8 divided by 10, which simplifies to be 4 divided by 5. Then we find tan, which is y over x, which is -6 divided by 8, simplified is -3 divided by 4. Next, we find secant, which is r divided by y, simplified is 5 divided by 4. Next is cosecant, r divided by x, which is 10 divided by 8, simplified is -5 divided by 3. Lastly is cotangent, which is x divided by y, which is 8 divided by -6, simplified is -4 over 3.
In quadrant 1, sine, cosine, and tangent are all positive, and in quadrant 2, sine is positive. In quadrant 3, tangent is positive, and finally in quadrant 4, cosine is positive. Use the first letter of the corresponding quadrant to determine which function is positive with the analogy A smart trig class. In quadrant 1, A goes to all. In quadrant 2, smart goes to sine. In quadrant 3, trig goes to tan. And in quadrant 4, class goes to cosine. 2 types of trigonometric identities are reciprocal identities and quotient identities. Some of the reciprocal identities are sine equals 1 over cosecant, cosine equals 1 over secant, tangent equals 1 over cotangent, cosecant equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tangent. In the quotient identities, tangent equals sine over cosine, and cotangent equals cosine over sine. We can use reciprocal identities and quotient identities to prove trigonometric identities. Now, prove the identities using quotient and reciprocal identities. In the first problem, we can turn cotangent into cosine over sine and multiply sine times cosine over sine to get sine cosine over sine. Then you can cancel out the two signs to get simply cosine. In the end, we got cosine equals cosine, so we did the problem correctly. In the second problem, we can distribute the sine to get sine times cotangent plus sine times secant. Then you simplify the cotangent and secants. The next step requires you to multiply the sine times cosine over sine, and then sine times 1 over cosine. When you simplify it, you get cosine plus sine over cosine. The last step is turning sine into cosine to tangent, then finally getting cosine plus tangent, matching the right side of the equation, meaning you did the problem correctly. Next is the Pythagorean identities. On the unit circle, the radius is always 1, the x is the horizontal, and the y is the vertical. If point xy is the point on the unit circle of radius r that corresponds to angle theta, then x squared plus y squared equals r squared. The three Pythagorean identities we use are sine squared theta plus cosine squared theta equals 1, 1 plus cotangent squared theta equals cosecant squared theta, and tangent squared theta plus 1 equals secant squared theta. Finally, we can insert numbers into the Pythagorean identities problems. In the last problem, tan 20 degrees minus sine 20 degrees over cosine 20 degrees, we can convert the tan 20 degrees into sine 20 over cosine 20. Then we can subtract, and it equals 0.
Thank you for watching.